Okay, well, let's go ahead and start scripting. And what I'll do is I'll select asteroid first. Scroll down over here in the inspector, click Add Component, and I want to create a new script. And the name of the new script is going to be projectile, capital P, projectile dragging. Press Enter. And let me just make sure that that's inside of the scripts. It's probably over here in Assets. Here it is. Take this guy, let me drag this over to, oh wait a minute, I don't have a scripts folder. Well, better create a scripts folder. So I'll click Create Folder, type in scripts, and then I'll take the projectile dragging scripts and drag it right here. Now if I go into the scripts folder, here we go. Projectile dragging. So let me double click this so we can open it up in MonoDevelop. Now I like to have a split screen type of deal, so I'll take this and I'll drag it over here to my other screen. That way I can just simply go back and forth between Unity and MonoDevelop. Okay, well, first of all, let me just have you type in some of the various private and public members that we're going to be using, and then I'll talk about them as the time comes along to describe what they're doing. So first I'm going to type in public. I'm going to type in line renderer, which is this guy right here. And we're going to call this catapult line front. We'll do the same thing again. Line renderer, catapult line back. And so the idea is when I move the asteroid around, select this guy over here, select the asteroid. When I move the asteroid around, we're going to need a line renderer, which is basically going to be a black line that goes from the front of the asteroid to this point, and then, if you can imagine, the back of the asteroid to this line over here. And so we're going to be creating that line through these line renders, which I'll talk about in a moment. Now we're also going to need some private members. Let's say private, and we'll type in spring joint. Now we created a spring joint 2D, and we'll just simply call that spring. Now the spring joint 2D is going to be a reference to the spring joint that we created right here. So over here in catapult, let's see here if I can find it. That's the line render. Did I put it as part of asteroid? Yeah, here it is. Sorry, part of asteroid. So this spring joint, I need to have a reference to that in code, and so that's what this is going to be. We're going to associate that in a bit. Okay, let's type in another private member, and we're going to call this transform. And this is basically, I'm just going to call it rock, and that's just simply the asteroid. And I want to create a reference to its transform data, so I can manipulate that. All right, let's see here. It looks like I'm also going to have another private value of type float. We're going to call that circle radius, and I'll show you what that is in a moment in terms of being able to change that. I want to know if, clicked on. I'm going to have this Boolean value called clicked on to indicate if whether or not the rock has in fact been clicked on, and to determine that state. So that's what this value is. Now, of course, this is a rigid body, the actual rock, so we'll create a private rigid body 2D. We'll just simply call that RB2D. We'll make an association with that. Remember that there's also a circle collider around the rock, right? There it is in green, so I want to have a reference to that. So we'll say private circle collider 2D. We'll just call it circle. And let's see here. Another thing that I want is the the previous velocity. I'll talk about this in just a moment. But the idea is prior to, well, actually, when I let go of this thing, and it's got a certain velocity here, velocity here, velocity here. So I always want to keep track of, even though it's getting a little faster, 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 when it reaches this point right here, what was the previous velocity? I want to keep track of that, and I'll show you why that's going to be important in a bit. So we'll say private vector2. We'll call this previous velocity. And then I want to keep track of the catapult location. All right, so down here, let me type private float origin catapult x, and we'll say private float origin catapult y. I'm going to be using these two values as calculations later on, but first let me get what those two values are. So let me say equals, let's go back over here, and let me select the catapult, and it looks like the x-axis is located at negative 11.13. So we'll say negative 11.13. This is where we're starting off the value. This is a float, so we'll put the letter F after it. And then over here, in terms of the y-axis, it looks like it's negative 5.61. So we'll say negative 5.61, and again, I'll put the letter F. So we're just keeping track of where the catapult is initially when I start my game. Let me go ahead and save my work and go from there. Okay, good. All right, well, the first thing that I'm going to do is I'm going to create an awake function. So we'll type in void awake, open and close parens, open and close curly braces. Now, what's the difference between the awake function and the start function? Well, the awake function gets called first. It's basically a function that indicates those things that must be done immediately, even before the start function. So these are the things that I'm saying need to be done first and foremost. In terms of the spring, let's go ahead and get the component. So we're going to type in spring joint 2D, open and close parentheses. So what this is going to do is, okay, first of all, remember, this projectile dragging script is tied to the asteroid. See, projectile dragging script. It is tied to the asteroid. Well, with this asteroid, I have a rigid body 2D, a circle collider 2D, a spring joint 2D, and so I need to get a reference to those various items here within the graphical side. So on the code side, what this statement does is says, yeah, get the spring joint 2D that's associated with the thing that's associated with the script. Well, that's this projectile. This projectile has a spring joint 2D, and so that's what I'm trying to get. I'm trying to get the projectile's spring joint 2D. All right, similarly, we have a rigid body 2D, so we'll say RB2D, and again, get component, the rigid body 2D, oops, sorry, capital R, rigid body 2D, this guy right here, open and close parens. So now there's a reference tied to the projectile's rigid body 2D component, which is this guy right here. Okay, let's actually get component. Let's actually get a reference to the transform of this object. So in other words, what we're saying is, yeah, this projectile, the asteroid, I want access to the transform data. Circle, get component, circle, collider 2D, open and close parens, semicolon. So what we're saying here is, yeah, in terms of the projectile, let's get its circle collider 2D. See, so the asteroid has a circle collider 2D. Let's get access to that. And here in the code, we're going to refer to that as circle. Now, in the previous past minutes or so, I had indicated that you can take the catapult, specifically for the line render, and you can change the width in this section over here, but I ended up doing it programmatically. And so what I'm saying over here is the catapult line front, here it is. I'm going to change its width multiplier specifically to 0.2. Put an F there because that's a floating value. And then the catapult line back dot width multiplier, I'll change that to 0.2F as well. Okay, the next thing that we want to work on, now that we've finished this information about the catapult line that we're going to be drawing between our asteroid and our catapult, is let's go ahead and create another function here so we can at least display the information, or display those lines. And that function will be called line renderer setup. Renderer setup. And let me move this up a little bit here so we can see what it looks like. Okay, so the first thing that we're going to do is let me show you over here in terms of this catapult, or in terms of this the line renderer that we want to draw. We are going to refer to the catapult's line, and I think, let me see, did we already set this up? Yeah, so catapult line front, catapult line back, and those are the lines that are going to be drawn from around the asteroid to this part and all the way to this part over here. Okay, so we'll type the following. We'll say catapult line front dot set position 0. Okay, well, first of all, before I continue on, notice that we are looking for the index of the catapult set position, and then we're going to give it a vector 3 position. So you're going to type in 0 and then catapult line front dot transform dot position. Alright, let's go back over here. So let's select our catapult. Alright, so this guy over here is our catapult front. Right here, this is the part that's most in front. This is the catapult back. This is the part that's behind. And so what I want to do is I want to set the positions, and you'll notice over here where it says line renderer, you'll see over here it says positions, and here it says element 0 and element 1. Okay, let's see what happens here if I change this X to 10, say for example. Or if I change this X to 10, say for example. Okay, well actually you don't see anything here. But what's actually happening is we are changing the X1, Y1, and the X2, Y2 values for the line render. And again, we're not seeing anything right now because we have to actually draw this, and that's what we're about to do. So this refers to like the beginning point and the ending point. And what we're saying here in this code is starting from position 0, so this would be like this guy over here, element 0, and then what would be these values over here for X, Y, and Z. And what we're saying is, hey, just take that catapult line front and get its transform, specifically its position. So where is this thing? For front, let me select that. Okay, so where is this thing located? And in the inspector, I have all this information over here. Yeah, wherever that position is located, that's what I want in terms of my vector 3 position. We're going to do the same thing for catapult line back. Again, set position. And once again, we'll say 0, but this time we'll say catapult back transform dot position. And the same reasoning here. I want to set that position based on where you're located, and that's going to be for index 0. So again, for this back part right here, specifically for our line renderer, we're trying to set up this element 0 position based on where the transform is for that catapult back. Okay. Another thing that we want to do programmatically is we want to set when we're creating this line renderer, well, see, I'm in design view right now, so I can't see the line renderer. But do you remember this business over here where we talked about sorting layer, and that within, if we set up stuff in the foreground, we can also give it an order in the layer. So I want everything to be in the foreground, well, with exception to the sky. I don't think I want the sky in the background or in this foreground area. Everything else I want in the foreground layer, and then I want to be able to determine what its order in the layer is. And so I can only do that in runtime, so we'll do this. We'll say catapult, line front, and we'll say dot sorting layer name, and we call it foreground. Oops, just like that. So let's go back over here, verify, yep, the sorting layer, we called that foreground. And so that means that when we draw the line renderer, we want that to appear in the foreground sorting layer name. And we're going to do the same thing for catapult line back, sorting layer name, once again, foreground. Okay, now, if we have this catapult and this part of the catapult line, and then we're also going to have the line renderer that's going to be extending from this point back behind the asteroid to this point over here, what is the ordering that we want? Okay, so let's see here. If I look over here, it looks like this is order in layer 0, and if I want that line to be right here, that would be at 1. And then this will be 2, and then maybe I want the line to be over here in the front, so that would be 3. So you can see here how you can, you have to keep track of the ordering here of where you want that line to appear. Shall it appear back here? Shall it appear back here? So let's just put some values down, and then we can correct them later if it doesn't look right. And the way that we're going to do that is we'll say catapult line front, sorting order. And for the front, we'll say, make that 3. Catapult, back dot sorting order, and we'll make that 1. I may have to change this to 4. I may have to change this to 0. I don't know. Let's just put something down, and then based graphically what it looks like, then we can make those necessary changes. Okay, well, I'm going to want to call this line render setup function, and I want to call it as soon as the game starts. So we're going to go over here to the start function, and we'll say line render setup. So it calls this function immediately. And then what we'll do is we'll also need to take into consideration the radius. And let me talk about that, the radius of this guy right here. See, what's going to happen is we're going to draw a line from here, and it will go to the center of the asteroid, but that's not what we want. We want the line to go and mimic as if it's going to the back of the asteroid, right? As if there's a rubber band that's wrapping around the back of the asteroid and then connect to the catapult. If we just go to the asteroid, it's going to automatically pick its center point. So what I need to know is I need to know this little distance right here. Right? If I know that distance, the radius of this asteroid, then I can say to the line renderer, don't just go to here, go all the way back, or so go to here and then add the radius so it looks like as if it's wrapping around the back of the asteroid. So over here, we're going to say circle radius, and that's going to be circle dot radius. Okay. So those are variables that I had you create over here. So notice what the circle radius is just simply some float value that's going to eventually be the circle, or the radius rather, of the asteroid. And so what did we assign to this? We assigned the radius value of circle. Okay, well, what is circle? Circle is our circle collider 2D. So in other words, this guy, the asteroid, has a circle collider 2D, and so let's see, here it is right here. So it's got a certain radius, and so I want to get that value, and then I want to add that, or I'm going to add that later on to the additional line renderer that we're going to be drawing in just a moment. Okay, well, let's do some experimentation and see where we are at this point. So first of all, I'm going to save my work, switch over here, and let's select asteroid, and you'll notice over here at the bottom where we have our projectile dragging script, I have these two public members that I need to fulfill. It says catapult line front, catapult line back. So I'm just simply going to drag and drop these items over here of the catapult. So I'll just drag catapult front over here to the top. And this top parent option is the catapult back. So I'll just drag that into here. Okay, and let's run and see what happens. So go into our game mode. Oh, look at this. Okay, well, first of all, you'll notice that our line renderer is extending out to the center of the scene, and that's what happens by default. We've got our position 0 set up, but we don't have our position 1 set up, and so it's going to draw to the center of the screen, the center of the scene, I should say. That's the default location. Here's another thing to consider also. Let me zoom in here, and you'll notice that the line renderer begins over here. Okay, so first of all, we have this part of the catapult. Then we have the line renderer, which represents the band. So first of all, it needs to be a little thicker. And then we have this part, and then we have the band out here. Well, I guess we just have to determine where you want the band. Do you want the band on the outside? So then this would be okay, but this has to go on the other side of the catapult. Or do you want the band on the inside? If that's the case, this line is okay, but this one would need to go on the other side. So this layer here would have to be in front of this line renderer variable, or level, I should say, layer. Okay, so a couple things to consider. First of all, that's not good. Line needs to be a little bit thicker. Maybe we should think about the layering. So first of all, let me stop this and let's go back to the code and see if we can make some adjustments. What if I wanted the bands to be on the inside? So then I'll change this to 2, save my work, go back over here, let's run again and see what happens. So now, when I zoom in, okay, so this line now is the inside, so it's going over here, it's on the inside of this. And again, it just depends on what you want to do. Here the band is on the inside of this fork, this line is on the inside of this fork. If you didn't want that, you want them on the outside, then all you're simply doing, oops, sorry, zoom out here. All you're simply going to have to do is just simply change the layering order or the sorting order, whatever you want. Now, I don't want to change the function. This function is, good the way it is. But at least to demonstrate how to get this line, from extending from the catapult to the center of the scene, I want that to really go to the asteroid. At least just to demonstrate that. Let me show you this. So let's take this guy over here. I'm going to copy it. Now, you don't have to do this. This is more for like just theoretical or understanding what's actually happening. So I've got the position 0, but it's the position 1 that I need to finish. I need that position 1 to terminate over here by the asteroid. So I'm going to affect position 1. And again, I want that to be where the asteroid is. Well, where is this asteroid? Right now, it is at this location, -14 and -6. So I think what I'll do is I'll say, instead of this is going to be a new vector 3 position. So I'll say new vector 3. And again, this is just to demonstrate to you what this would look like. Okay, so -14.64. That's where this is in terms of its x-axis. -14.64. Okay, so -14.64, comma. Where's your y location? -6.29. Okay, so -6.29. Whoa, what am I doing? Comma, -6.29, comma, and then your z-axis is 0. So 0. And by the way, put letter F's in front of these, otherwise you're going to get an error. Because these are vector values. And what I'll do is I'll just simply, or these are float values, that's why you put the F there. And I'll just simply copy and paste, put that right here. So in essence what I'm doing is I'm saying here's where your 0 location is. It's where your catapult line front or catapult line back, where your transform position is. So in other words, your lines are going to start here and here. Now, where is the other part of the line, right? Because the line has to have 2 points. Well, your position 1, you saw how this thing extended. This was position 0, this is position 1. And so what I'm saying is your position 1 is now going to be where the asteroid is. And so I just took the values for the asteroid, which are here, and plugged them into here. All right, so let me save my work. Go back over here, run, and let's see what happens now. Sweet! So you see that the lines now go to the asteroid. Now, this is not correct because it's supposed to go to the back of the asteroid. But notice what's happening. The lines are going to the center of the asteroid. So if I just added the radius, excuse me, if I just added the radius a little bit, then it would look as if the band is going in the back of the asteroid and then to one of these forks. Okay, so first of all, what I need to do is I need to increase the size of the band. That's too thin. So let me go back over here. I'm going to get rid of this. This was just for me to demonstrate this whole business of position 1 and position 0. So let me get rid of this line right here. And let's see what 0.4 looks like. Maybe 0.5. So 0.5, save, and let me go back over here. And let's see what that looks like. Okay, we're looking a little bit better. And I know I took off that 2 lines of code, so it looks like it's going to extend out of here. We'll fix that later. Right now we're just focusing on the thickness of the line. That's still too thin. So let's go back over here. Let me stop the code. And let's see here. How about 0.8, say for example. Save. Go back over here. Run. Okay, it's looking better. Personally, I don't like this where, whoops, sorry, let me use Alt. I don't like this where the band is on the inside. I think I'm going to prefer it where the band is on the outside. So I need to change the layering order. But okay, definitely the line thickness is looking a lot better. So let's go back over here to the code and let's see here. So the sorting order for the back, I'm going to change this to 0 because I want it to be behind this fork. 2 is behind this fork, so I'm going to make that a 3 so that it'll be in the front of that fork. Well, before I do any adjustments to the layering, let me save my work, or not to the layering, the width. Let me save my work, run the code, run the game, let's see what happens. Okay, I like this better. It looks like the band is on the outside of each of the different forks. I'm okay with this width. That width, yeah, I'm okay. I mean, if you want to change it, that's fine. You would just simply, change it over here. So say, for example, maybe we want to change the front to 1.0. Save my work. Go back over here. So let's see here. So you can see that the front is a little bit thicker than the back, kind of giving it this three-dimensional appearance. And when the line is now going to be pointing back towards the asteroid, I think this is going to look a little bit better. So I can leave it like that. That's fine. Okay, so let's work on the line not shooting off into space to the center of the scene. Let's make the line so that it's going to go back. Position 0 is here. Position 1 will be behind the asteroid, going from one fork of the catapult to the next fork of the catapult. So let's go back over here to our code, and let's create another function. And we're going to say this is called the line renderer update. Like that. Okay, good. Now, the line renderer update will be the redrawing of the line from wherever the asteroid is and drawing those lines to wherever the catapult forks are. And I haven't generated the code yet to actually drag this asteroid. We'll do that in a moment, but when we do drag the asteroid around, we're going to want there to be this line out. This is just the spring joint 2D line. eventually this is going to be that line render. So no matter where I place this thing, right? So I want to make sure to draw that wherever this thing is being dragged. So let's take care of that via this. This is part 1, drawing the line render update. And so the first thing I'm going to do is I'm going to create a vector 2 called catapult to projectile. All right, first of all, let me stop. Catapult to projectile. Okay, so catapult to projectile. I need to draw a vector 2D, or create a vector 2D line. And so all I'm going to do is take the transform, which is, in this case, this is the transform of the projectile or the asteroid, and get its position. And I'm going to subtract from that, and I'll say catapult line front dot transform dot position. So again, I'm just getting that distance from here to here, the center of the asteroid, and I'm going to call that catapult to projectile. Okay, now before I continue on, there's one additional item that I did not include yet in terms of my declarations, because I wanted to talk about it first. And that is this idea of drawing a ray, or actually you don't draw a ray. A ray, as you can see here, is an infinite line starting at an origin and going in some direction. So it's an invisible line, but we need the usage of this line, and here's why. Okay, so let me see if I can select the asteroid here, because it's got this spring joint, and this is going to represent eventually my ray. Because what I need to do is I need to say, okay, whatever that distance is from here to here, I need you to add the distance of the radius. But, you know, is it going to terminate over here at this point? Is it going to terminate over here? No, obviously we want the rubber band to terminate right around here. So I need the radius to go all the way to this point in the same direction as this ray that I'm going to be drawing. That's going to be basically the same direction, the same slope as this line over here. So how do I go about doing that? Drawing a ray, which is one of these guys, which is a line that basically is the same thing. Think of a line that's on top of this green line, same direction, and I only want it to go a little bit more after the center point here, specifically the radius length, in the same direction as this green line, which is what my ray is going to represent. Okay, well, in order for me to do that, let me go back to the top here. And let's see here. I'm going to go back over here. And we'll just put this under line renderer. Actually, it's going to be private, so I can just put it at the top over here. That's fine. So I'll just say private. And this is going to be of type ray. And we'll say this is going to be left catapult to projectile, and this is going to be ray. Okay, so from the left catapult to the projectile, from the left catapult to the projectile. So whatever that line looks like, and the green line in this particular case represents this ray, but no matter where this thing is going to be positioned, the asteroid that is, this ray will always be from this point to that location, and then I'm going to add to it the radius so I know where the band is supposed to go behind, or the line renderer. Okay? Alright, so I have this, and let me just take a look at my notes here, make sure that I'm following along correctly. It looks like I'm going to have to also go to the Start menu and give this thing an initial value. So over here, after the line renderer, we'll just say left catapult to projectile ray. This is going to be instantiating a new ray, and we'll just say catapult line front dot transform dot position, and then vector 3 dot 0. In other words, we don't have a z component. We're only interested in the x and y component. All right, so what this thing does is it's saying, okay, let's get that catapult line front, which we created this right here, right? That's going to be our line renderer. So the line renderer, let's get that position, and that is basically what our ray is going to be. The ray is going to superimpose on top of the catapult line front, so that we can use that to add the additional radius amount. So now that we have that, I can go over here to the line render update, and now I can type in the following. We'll say left catapult to projectile ray dot direction, right? And you know why I'm doing this, because that's what I want. I want the direction of this thing, and then I want to add that little bit of radius distance. This is eventually what I'm going to be doing. So the left catapult to projectile ray dot direction, that's going to be the same thing as my catapult to projectile. Oops, sorry. Catapult to projectile. Let me just start all over again so that way I can select the appropriate one. Left catapult, I'm sorry, not left, catapult to projectile, this guy right here. Okay, that's what I created up here. And what is the catapult to projectile? Well, that's the transform position. In other words, this script belongs to the rock, to the asteroid. So it's the position from wherever the rock is to the catapult line front transform position. So in other words, from here to here. So front is right here. This is the front right here. So we're going basically to the front. And once I have that, okay, so now I can say, okay, well, this thing here, this ray, it's going to be basically the same direction as this guy right here. Well, once I have that direction, let me go ahead and create a vector 3. I'll call this hold point. What is hold point going to be? Hold point is eventually going to be this right here, this point. And so that way I have a point from here to here, and then I can just draw, no matter however I drag this asteroid, it will always have a point from here to the catapult. So hold point is going to be left catapult to projectile ray dot get point. Let's see here, what does this say? Returns a point at distance units along the ray. Well, that's exactly what I want. Specifically, let's take that catapult to projectile dot magnitude. What does this thing do? Magnitude. Returns the length of this vector. So in other words, the length of the vector from the catapult to the projectile, the length of this line right here, from here to here, that's what dot magnitude is. So this is returning a float. As you can see over here, it says float. See if I can go back on here. Oops, it's disappearing. Okay, so that's returning a float, plus the circle radius, which, as you can see here, is another float. So in essence, what this is doing is it's saying, get this line from here to here, get that distance or magnitude, and then add to it that circle radius. So that way I can say from this point to the catapult, draw your line renderer. Okay, well, once we've done that, then we'll just simply say catapult line front dot set position, this guy right here. Now position 1, as you'll recall, this is position 0. This will be position 1, because remember before how this was position 1 was stopping over here somewhere on the center of the scene? By default it's going to do that. Well, now we're going to instruct, oh, by the way, your second point, right? Because all lines have 2 points and they have a starting point. Your ending point is not going to be out here in space. Your ending point is going to be behind the asteroid. And so that's what we're saying. This position 1 is behind the asteroid. And where is that? That's at hold point, the thing that I just evaluated. And we'll do the same thing for the line back. Dot set position. Once again, that terminal point is going to be behind the asteroid. So remember, the 0 is this point right here. The 1 is this point of a line. But I don't want this point, sorry. I want it with the radius back here. Okay, so that's the line renderer, and we are going to call that in update. So now this is not complete code here. I'm just going to type this in so that we can demonstrate this. So I'll say call the line renderer update. Right, this is not correct. I'm going to erase this eventually. But just to demonstrate what's happening over here, let me save this code, go back over here, run it, and let's see what happens. Okay, cool. So notice what's happening. We are drawing a line from this point behind the well, I shouldn't say behind the asteroid. It looks like it's behind the asteroid. All we're doing is just simply taking this plus the radius, and notice that this little chunk right here is in the same direction as the ray, and the same thing for the back. And for the back, you'll see that there's a line that starts over here and goes all the way, but it doesn't matter because in terms of its layer, it's behind. So this is like the line over here represents the back flash card. This is a flash card in front of that line. Then I have this line over here that's behind this fork, and then finally the fork is all the way in front of us. Now, I move this around, and look at what happens. Now, I'm moving this around in the scene view, and if I go to the game view, it's not doing that, right? So this is I'm cheating a little bit here. Eventually, this is what I want. I want this behavior where no matter where I'm stretching this thing, as you can see here, right? Isn't that pretty cool? The line is going to be redrawn. Okay. Well, let's start thinking about the code that's going to be necessary for me to use my mouse to click on this asteroid and then pull it back to wherever position, because eventually I'm going to let it go and this thing's going to sling forward so that I can attack the house of the angry animals. I don't want to be doing this in the scene view because obviously the user doesn't have access to this. We want to do this somewhere over here, right, in the game view. So let's deal with that. Let me go ahead and create another function. First, let me clean this up a little bit. And I'm not going to do this. Let me just comment this out to remind myself that I'm not going to just simply put this in update. This has to be based on a condition, which I'll talk about momentarily. So let's go ahead and create a function called dragging. Alright, so in dragging, the first thing that I'm going to do is to create a vector3 called mouse world point. And what are we going to assign to that? So let's type camera dot main dot screen to world point. This guy right here. And then the input is going to be my mouse position. Transforms positions from screen space into world space. Okay, the long and the short of it is I want to get where my mouse is positioned in 3D space on my game. Now I know that I have a 2D game, but you know that all 2D games are really just on top of a 3D world, as you can see right here. Right? So, right, and there's the camera, and my mouse is going to be somewhere on this screen. So what I'm trying to do with this code is I'm trying to say, where is our mouse? Because based on where our mouse is, that's where I want my rock to be, or my asteroid, right? As I'm moving this thing around. Go back over here. As I am moving this thing around with my mouse, I want it to follow my mouse. Right? Okay, so how do I do that? So first of all, I want to find out where the mouse is. Second, we're going to create a vector2. We'll call this catapult to mouse. I think you understand what that is. From the catapult to wherever the mouse is. Where, what is that? What is that vector? So what we're going to do is we're going to say mouse world point minus new vector3. Now I know that we're putting this into a vector2, but I'm just going to make the z-axis 0. And we'll take the origin of the catapult X, which is something that I created when I first started my program. I simply went to the distance or the location of the catapult. I got that from the transform, and I plugged those values in here. So now I'm using them here, comma, origin of the catapult Y, and then I'm not worried about the Z axis. So I'll put 0 there. All right, now that I have that, let's go ahead and, when I'm dragging, I want to make sure that I'm able to move the rock around. So I'll say mouse world point dot Z axis. I don't want to do this in 3-dimensional space. I'm only playing this game in 2-dimensional space. So what I'm going to do is I'm going to say there is no Z axis. Don't worry about this. And then I can affect the transform, which, remember, this script belongs to the asteroid. So I'm talking about the transform of the asteroid, specifically the position. And what we're going to do is we're just simply going to say that's going to be mouse world point. So in essence, what this code is doing is it's saying, hey, wherever you're dragging the mouse, that's where I want your rock to be positioned, or that's where I want your asteroid to be positioned. Don't worry about the Z-axis because we're dealing with a 2D game. Okay, so this dragging function must be called if I want to, or when I move the rock around. So when should I call this? Well, let's go back over here to update. And I created some additional variables over here. Let's see here. Where is my clicked on? Oh, here it is. Clicked on. So if the user clicks on this asteroid, if clicking mode is on, then this is the behavior I want. When the user lifts up, then this thing is going to sling forward. Okay, so let me state this again. When the mouse is down, I want something to happen. Okay, so let's go back over here to the code. And let me go ahead and create a function called void on mouse down. Now this is a function that Unity allows me to use. In other words, when the mouse is down, what do you want me to do? Well, I want you to change the value of clicked on to true. Now, by the way, I also want you to do this. We'll say spring dot enabled. We're going to set that to false. All right, that's going to come in. That's going to be relevant later on, but let me at least explain now what's going on. All right, so when the mouse is down, I want this type of behavior. I'm moving the rock around. Well, I don't want the spring to be activated. I want the spring to go ahead and launch this thing. Not yet, because I'm moving this thing around. So that's what this means. In terms of the spring enabled, yeah, it's disabled. We're not allowing the spring to do its job. Right now, we're with the mouse down, we are moving the rock around, and so since the user has clicked down on the mouse, we have this flag that is saying, yeah, clicked on, true. The user is in this click down mode. And then what we need to think about is what's going to happen when the user releases the mouse button. Okay, so let's create another function called on mouse up. Spelling is important. This is not my function. This is a function that belongs to Unity, and this is going to be called when the user lets go of the mouse button. Well, if it stands to reason that I should disable the spring while the user is moving the rock around, then that means that over here, spring.enabled, we're going to set this to true when the user lets go of the mouse button. Right? We want the spring to go ahead and do its job. Now, let me talk about this. With this rock, right, so let me select asteroid. Let's see here. Rigid body 2D. Oh, it's set initially to kinematic. It's not set to dynamic. And the reason why we set it to kinematic is because we don't want physics forces to act on this thing yet. What I want to do is I want to be able to move it around And then when I let go, then it's going to be a dynamic rigid body 2D. In other words, we want physics to act on this rock because it's going to have this parabolic shape as it flies through space. Okay. So, go back over here. We'll say the RB2D, which is the rigid body of the asteroid, is kinematic. We'll set that to false. We want it to be dynamic now. In other words, we want physics forces to act on this thing. And then I'm going to change this flag, which I created called clicked on, to false. Yeah, I'm not clicking it anymore. If the mouse is up, it's not in the clicked on mode. I've lifted it up. So now let's go ahead and begin this launch process. Okay, so now let's go to update and let's put all this stuff together. Remember, update is going to be called once per frame. And let's see here. If clicked on is true, open and close curly braces. Now, I don't have to do this. Certainly, this is readable code. If this value is set to true, what I could do is this. Right. The only way that this if statement is going to execute is if the predicate or the Boolean expression is in fact true. So however you want to set it up, that's fine. You're just simply saying, hey, if this thing is true where the user has clicked on the, or the mouse is clicked down, I should say, and obviously we're going to click on the asteroid, then we're going to activate this dragging function. And you know what the dragging function does. It basically moves around the asteroid. Okay, so that's if the user has clicked on. All right, what else are we going to consider? Let's have another if statement. If spring is not null. Open and close curly braces. Well, let's go back over here. What is spring? Let's see if I can find it over here. Here it is. Spring is a spring joint 2D. It's basically this guy that belongs to the asteroid. This guy right here. Right? Because that's what this code is. This code is referring to this asteroid. It's going to be affected. It's going to be affecting the asteroid. And so I created spring, which is this spring joint 2D. Okay, here we are getting the component in the awake function. So what we're going to do is we're going to say, hey, as long as this thing is not assigned to something, right? So it's not null, it's not empty. In this case, we did assign it. We assigned it to the actual spring joint 2D that belongs to this asteroid. All right, if that's the case, then we're just simply going to call line renderer update. Open and close parentheses and semicolon. Now, let me see here. Looking at my example code here, making sure that I'm copying everything over correctly. And what I want to do is I want to have an else statement that goes along. Oops, sorry. This else statement is going to be the alternative to the spring being assigned to nothing. And what I'm going to type over here, so let me just put a comment here. Otherwise, our catapult lines are disabled. So when I'm dragging this thing around, we're going to see catapult lines. When I let go of it, no more catapult lines, especially when this thing is flying forward. Right? We want to disable those catapult lines. We don't want them to be always displayed. That's what we're doing in our particular program. So I'll click back over here and we'll just simply say catapult line front enabled is false. Catapult line back enabled, that's also false. So in other words, we're going to eventually destroy the spring joint 2D, and when we destroy that, that's when we keep on calling line render update as long as the spring is not equal to null. Otherwise, when we're in launch mode, let's disable those. Okay, so I think we're done. Let's go ahead and save our code. So File, Save, or Command S. And let me go over here to Unity. And I think that's too far away. Let's start off with something like that. Let me go ahead and maximize on play. And let's go into play mode. Okay. So first of all, can I move this thing around? Ah, nice. Look at that. So I can move this thing around. Very cool. I like it. Let me start off with something like this. Let go. Beautiful. See, when we first start our game, we want this thing to be in the kinematic mode, not in the dynamic mode. And then when we let go, that's when we want this thing to go into dynamic mode and have physics forces applied to the asteroid. So let me pull back a little bit more. Very good. Now we're going to have to fix this business of when the asteroid goes off screen. We're going to want to move the camera. We're going to want to move the scene over a little bit so that we can see where it lands and the destruction that it does to the farm. Okay, I'll take off maximize on play. And let's see what happens when I pull all the way back like to here. Wow, very nice. And let me play one more time. Did I not click it? Here we go. And let's try something crazy like this. Okay, wow. I don't think it should have done that. That's a bug. Let me try it again. And let's see here. It should bounce off the ground. There we go. All right, so you could see what happens in terms of getting this thing to drag around. That's what this dragging function is all about. But we're only going to call this if the user is clicking down on this. And then over here it says click down set to true. Well, if clicked on I should say. If clicked on is set to true, then we are in the dragging mode, which means that we can move the rock around based on the mouse position. That's in essence what this code is doing. Now, once I let go of this, then we are no longer going to be in the clicked on mode. So that means what we're going to do is we're going to say, hey, as long as this spring is not referring to anything, then you're going to call the line renderer update. Otherwise, otherwise our catapult lines are disabled, so we're going to take those catapult lines for the front and the back, and we'll set them to false so that they are no longer displayed. And so let me just go back over here and show you that. So as soon as I let go, watch these black catapult lines. What happens? As soon as I let go, they disappear. Okay. Now that would be cool, right? To make it so that, and refine the code so that maybe we can have these lines just like go back and forth like this to simulate what that would look like, what a real catapult would look like. So the asteroid would continue flying, but the lines would maybe go something like this, and then maybe they would dangle down like this. That would be really cool. I'll leave that as a future project to you. Right now, I'm just satisfied with being able to pull this thing back. The lines are going to tag along wherever the mouse is located, and then let go. And they are no longer visible. That's okay with me. All right, there's something else that I just noticed as I was looking at my notes that I forgot to place in my code. You probably have caught on to it. The idea is that when the spring is not equal to null, okay, well, as long as it exists, it's always going to call this. But at some point, I don't want it to exist. That is when I launch the projectile. Well, so when I launch the projectile, we want to disable those line renderers. And what we'll do is we'll just simply say destroy spring. Okay, so it no longer exists, and if it no longer exists, then we're no longer calling the line renderer because there's nothing to update. Let me save this. Go back over here. You won't really notice a difference here. If I move this thing around, no big deal, and then as soon as I let it go, yeah, no big deal. But perhaps if I were to place some printable lines to show you where we are located, maybe that might be helpful. So let's see here. What if I do this? What if I say, okay, so if we're in this area, then we're going to say print. We'll say we're dragging. Right, we're in the dragging mode. And maybe we'll say click on equals true. Right, just a simple string to help us to display where are we located, in what mode, in which if statement are we located. And for this guy, we'll just simply say let's see here, we'll say spring is not equal to null. In other words, the spring exists. And maybe we'll put another print statement over here, which is going to destroy the spring. Destroy spring. And let's see, we want to figure out, or we want to make sure that we're displaying when the mouse is down. So we'll say on mouse down. And same thing over here. On mouse up. Okay, let me save my code. And let me go back over here. And on the bottom right hand side, this is where my console comments are going to come in. And I can drag and drop this thing to wherever I want. So I think I'll just put it up here. I'll take this guy and drag it right next to this tab over here so that it'll be on the same level of these tabs. I can go into scene view. Here's the asset store. I can go on the console. Let me clear this. And I'll be able to see comments, or these printable comments over here, printable lines. I'll see them here when I'm running the program. So let me go into play mode. Okay, and here we are. And see, this is an indication of how many times this is being called. So it looks like it's calling this spring is not equal to null. So in other words, our update is going into this mode over here, and it's printing this, and it's calling the line render update. And so that's basically what this thing doing. It's just rendering these lines. Okay, so as soon as I press the mouse down, then we should see this, and then the spring enabled will be false, and then we'll say clicked on equals true. Well, if clicked on is equal to true, then we should see this for a brief moment, and then we're going to be calling dragging. And so in this case, we're going to see that dragging. So let's see what happens here. So I'm going to click, hold this down, move it around, and you can see over here it says dragging. And now let me let it go, and so now it says destroy spring. We're calling that over and over and over again. And that makes sense because the spring, since I destroyed it, the spring does not exist. So this is going to go over here. There's no need to call the line renderer update because there are no lines to render because we've destroyed the spring. So the way that I'm going to work on the next part of the program is I'm going to say, all right, well, first of all, when this rock launches, we're going to destroy houses, and then when the rock comes to a stop, when there's no more velocity, then we just simply reset the game. We'll also make it so that if the user presses the R key on the keyboard, that resets the game. And if we reset the game, then we're basically calling this script again. And if we're calling this script again, we're going to create a brand new Spring Joint 2D, which we're going to call Spring. And this whole process begins all over again. Because in essence, we're restarting the game. We're playing the game all over again.